cloud native capabilities. Now, once you have this in place, for example, you could have hypervisor or you could run this on bare metal. But once you have this compute storage network layer, then comes in the container native or the cloud native layers or the counterparts for each of them. So let's take a look at them. So the first one is the container optimized operating system. So operating system has gone through a significant change in the context of containers. You actually don't need to run fully fledged operating systems. You can run minimalistic, lower footprint capabilities of an operating system to avoid your vulnerabilities on the attack surface, because the smaller the footprint, the better the security. So there are new breed of container optimized operating systems that are designed to run containerized workloads and Kubernetes. So let's take a look at them. So there is CoreOS, which is now acquired by Red Hat, and it is called Red Hat Enterprise Linux CoreOS or Fedora CoreOS. It's a commercial offering from Red Hat. And there is another company called Talos, which is actually building an OS for Kubernetes called Talos. And when it comes to open source, there is a port of the original CoreOS that is called Flatcar Container Linux from Kinvolk, and now it's a part of Microsoft. Recently, Microsoft acquired them. It's an open source operating system. So these are the container optimized operating systems which offer very low footprint and highly optimized OS layer to run your stack. Now, once you choose the operating system, you have the core building blocks, that is container runtime, container native storage, and container native network for the cloud native stack. So this sits a layer above your physical compute or virtual compute storage and network layers and give you a very different environment that is highly optimized for containers. So container runtime is basically the interface between the operating system, that is the kernel, and the containers running on top. I'm sure you're familiar with Docker. Docker is one of the container engines or runtimes. When it comes to commercial, there is Mirantis Container Runtime, which is actually the Docker Enterprise, which is rebranded after the acquisition by Mirantis. Then you have a variety of open source projects. So you have Containerd, Cryo, Docker, Community Engine, Kata Containers, Runc. Now, one thing that I want to call out is in this slide, you actually see a CNCF logo next to some of the open source projects. What it actually indicates is we have the CNCF inclusion for these projects. For example, Containerd is a CNCF project. Cryo is also a CNCF project. So every time you see a logo, that indicates it's not only an open source project, it's also a CNCF project. It could be a sandbox, it could be an incubated project, but it is going to be a CNCF project. That's what it actually conveys. Then comes in the storage, and you have a lot of commercial choices from Red Hat, from Maya Data, Pure Storage, and so on. You also have open source alternatives like Ceph, Rook, which are very popular, Longhorn from Rancher, OpenEBS from Maya Data, and all of them are a part of the CNCF ecosystem and part of CNCF. They are actually projects, either a sandbox or an incubated project under CNCF. So these are the new storage technologies or storage layers that run on top of your existing block storage or direct attached storage. Similarly, we have container native network. So container native network takes your virtual network or your software defined network to the next level by building subnets, bridges, and the network topology for your Kubernetes clusters and containerized workloads. There are commercial options as well as open source. For example, Project Calico is very popular among the ecosystem.